Welcome to this P3 presentation on acceleration and velocity. By the end of this presentation you should be able to do the following four things. Firstly, you're going to be able to calculate the acceleration of an object. Secondly, make sure you've got the right units. Thirdly, explain the difference between speed and velocity. And finally, understand and calculate relative velocity. There are four key words that you're going to need to know by the end of this session. They are acceleration, deceleration, velocity and relative velocity. I want you to pause this slide now and see if you can write a definition for each of those four words. Now you've had a chance to write your own definition, let's have a look at how they're defined in the textbook. Okay, so acceleration is change in velocity, and then if you look at deceleration, deceleration is also change in velocity. You can describe deceleration as a negative acceleration. It's exactly the same thing. And your final two, velocity is speed in a given direction, and it's this direction that's important. It doesn't really matter what the direction is as long as it's given. It can be south, north, up, down, left, right. It could even be 20 meters per second over there. Each one of those, because there's a direction given, that makes it a velocity. And then you have relative velocity, and relative velocity is the difference in velocity between two moving objects, and we'll have a closer look at that towards the end. Right, so we're going to start by looking at acceleration. Simplest way of thinking about acceleration is speeding up. Now you're going to need to know the equation. So acceleration here is the change in velocity divided by the time taken for the change. Now you may see this in terms of letters, and those letters are V and U, and obviously in the alphabet U comes before V, which is why U is the initial velocity or the starting velocity and V is the final velocity. So because U is before V, the initial comes before the final. So you take the final velocity, you subtract the initial velocity, and you divide it by the time taken for the change. So as with a lot of equations in physics, you can put these into a triangle. So there's acceleration, change in speed and time. And you cover up the thing that you're trying to find, and you can either multiply or divide the other two things to work out what it is. So if you take the change in speed and you divide that by the time, that's going to give you the acceleration. That's the one that's covered up there. We've now covered up change in speed, and change in speed is acceleration multiplied by time. And finally I'm going to cover up time, and when I do that I've got change in speed divided by acceleration gives me the time. Now one of the difficulties that people have with this is getting the units right, because quite often in exam questions there will be extra marks given for you to be able to get the units. So let's have a look at how this works. Okay, just like when we calculated speed, and if you've not looked at the speed presentation then I suggest you go back and look at that. This works exactly the same way. What you do with the numbers you do with the units. So acceleration, which is here, okay, acceleration, that shouldn't have moved. Acceleration is change in speed divided by time. So you've got meters per second divided by seconds. So here you've got meters per second divided by seconds. Now in my opinion that's quite a scruffy way of writing it, and so meters per second squared is a lot better. But if you were to write meters per second you wouldn't be wrong, but I prefer this one. So with the other versions of that equation, change in speed is acceleration multiplied by time. Well, we've said that acceleration is meters per second, so, and time is in seconds. Well, if I'm dividing by seconds and multiplying by seconds, they cancel each other out, and what you're left with is meters per second. And finally, if I've got time, change in speed divided by acceleration, so you've got meters per second divided by meters per second. If I take that meters per second and that meters per second, they cancel each other out. What am I left with? Seconds. So whatever you do to the numbers, you do to the units as well. So now I'm going to show you a worked example. Right, a car accelerates from 8 meters per second to 20 meters per second and takes 6 seconds to do it. What is the acceleration? I want you to pause the slide and I want you to try and work that out. Right, now you've had a chance to work that out, let's have a look at the equation, and I hope you've got the units as well. So the change in velocity is 20 minus 8, because 20 is the final velocity, 8 is the initial velocity, so 20 minus 8 gives you 12, and the time taken to do it was 6 seconds. So 12 divided by 6 is 2 meters per second, and of course we don't like that version, we're going to go for meters per second squared instead. Right, so now it's time to look at deceleration. If you think back to the key words, acceleration and deceleration are both changes in velocity. There really shouldn't be any difficulty with this because the equations are exactly. Yeah, and as it says here, when the initial velocity is greater than the final velocity, you slow down or decelerate. So if you think it in terms of this, you're a car going down the motorway and you're doing 70 miles an hour, and you put your foot on the brake and you do 50 miles an hour. So your initial velocity, what you're starting with, which is the 70 here, is greater than the final velocity. So you're slowing down. And as I said, we call this a negative acceleration. The equation's the same, the calculation's the same, it's just you're going to end up with a negative value because you've still got the final minus the initial divided by the time taken. Well, clearly, if your final is smaller than the initial, you're going to end up with a negative value. And now we're going to look at the difference between speed and velocity. Quite simply, this is about knowing which direction we're going in and how fast we're going in that direction. Right, we mentioned this before, this is from the speed revision session. Speed is distance divided by time. So in order to get velocity, all you need to do is you add a direction onto the end of that. So east or left or up or over there, all of those would be acceptable. Now we come to relative velocity. This is really about judging how fast you're going compared to another moving object that's going in the same direction or the opposite direction to you. So say you're going down the motorway and you overtake a car, the relative velocity is going to be the difference between the velocity you're going and the velocity that they're going. So let's have a look at this in action. Right, so this is you at the top, you're doing 20 meters per second. And the car at the bottom is doing 10 meters per second. So the relative velocity, you take your velocity, you subtract their velocity, and that gives you the relative velocity. The relative means the difference between you. But you need to give a direction because it's velocity, and these cars are both travelling to the right. As you can see, I've put the slides the wrong way round. I was supposed to put the blank one before I put the numbers in, but we'll move on. So with this one, again, you're moving to the right at 20 meters per second, but this car is going in the opposite direction as you. This is going 10 meters per second to the left. So the difference between the two is 20 plus 10, because you've got 20 in one direction and 10 in the other. So you've got 30 meters per second to the right. Now, you've got to think about this. If you're on a motorway and you hit the crash barrier in the middle, the crash barrier isn't moving. So if you're doing 70 miles an hour, then your overall velocity between you, the difference of velocity between you and the crash barrier, is 70 miles an hour. If you hit a car coming in the opposite direction, and that car is also doing 70 miles an hour, you've got your 70 miles an hour going one direction, you've got their 70 miles an hour going in the opposite direction, so the overall velocity of the crash is 140 miles an hour, because you've got the two added together. Yeah, and again, you can see I mucked up, I put those slides the wrong way round. And as usual, now it's the bit you've all been waiting for. It's the exam question time, and unfortunately for you, I have got the slides in the right order, so you're going to have a go at working them out before I give you the answers. Here's the first exam question. As I said, we'll go through the question, I want you to pause it and I want you to try and do the calculation, and then I'll show you the answer afterwards. So we've got Dave driving his car, and the car accelerates. The car on the left there is doing 11 meters per second, the one on the right is doing 3 meters per second, and it takes Dave 2 seconds to do that. Calculate the acceleration. As usual, you don't have to remember the equation. they're going to give you that on the exam paper, but don't forget they'll only give you one version of that, and you have got to be able to do that triangle in order to rearrange the equation if necessary. So pause this slide and work out the acceleration of the car, and then we'll look at the answer. Now you've had a chance to look at that, here's the answer. So you need to take the change in speed. So it started at 3 and went to 11 meters per second. So 11 minus 3 is 8, and it took him 2 seconds to do that. So 8 divided by 2 is actually 4. I don't know why it says 8 there. Let's scrub that out, and we'll put 4 in instead. Obviously I was a bit tired when I did this one, so sorry about that. Okay, now this one's a bit trickier. This car's about speed and acceleration. A car drives in a circle around a wall of death, and it's travelling at a constant speed. Explain how the car can be accelerating as well as travelling at a constant speed. And secondly, a BMW car, excellent make if I do say so myself, has an acceleration of 3.2 meters per second squared. How much time does it take to accelerate from 0 to 28 meters per second? Again, using the equations to help you. So time to pause it, answer those questions, and we'll come back in a couple of minutes and see how you get on. Right, the first one's quite tricky to explain very simply. Don't forget, with this you need to know the difference between speed and velocity, because speed is the amount of distance that you travel in a given time, and velocity is your speed in a given direction. Well, this car is travelling round here at a constant speed, so let's say 10 meters per second. So it's always doing 10 meters per second. The thing is, its direction is always changing, because at the moment that car is pointing that way, so it's doing 10 meters per second to the left. When it comes round to this side, it'll be going that way, so it'll be doing 10 meters per second to the right. So because velocity is in a given direction and the direction is always changing, a change in the speed is known as acceleration. So it says there, acceleration is change in velocity, and velocity is speed in a given direction, and the direction is constantly changing. Like I said, it's not easy to explain, but you probably get it in your head. And it's about getting it down on here that's the tricky bit. The second bit, BMW car has an acceleration of 3.2 meters per second squared. How much time does it take to accelerate from 0 to 28 meters per second? Right, so with this one, it's saying how much time. So you're going to have to rearrange the equation in order to make time the subject. So I've done that for you. Change in time is change in speed divided by acceleration. Well, we know the change in speed because we have the final speed, we have the initial speed. 28 minus 0 is obviously 28. And we know that it accelerates at 3.2 meters per second squared. So if we divide our change in speed by 3.2 meters per second squared, that gives you the answer 8.75 seconds. That's not bad acceleration if you ask me. I'm sure I could probably do quicker. Right, we're now coming to the end of this, so let's look at what you now should be able to do having watched this presentation. You should now be able to calculate the acceleration of the object, and you should be able to get the right units. Remember, you do to the units exactly the same as you do to the numbers, and you shouldn't go far wrong. Thirdly, you should be able to explain the difference between speed and velocity. It's that idea about the given direction. And finally, you should be able to understand and calculate the relative velocity. And of course, now we come to everyone's favourite. Still to come in this series, there are going to be sessions on distance time graphs and speed time graphs, and also how forces change the motion of objects. Now you really want to watch that one because there is quite a funny little video clip that goes with it. Made me actually laugh out loud. I'm not just saying lol for the sake of it, I did actually laugh out loud. So we'll see you next time when we do distance time graphs and speed time graphs.